So, continuing from the previous video. Now see, let C be the point where those objects meet. So, let this distance from here be x. It's obvious. Now, we know that the height of the tower is 100 meter high. So, this will be, so from this will be 100 minus x. So, this will be 100 minus x, means the distance BC is 100 minus x and AC is x. Okay. Now, taking the vertical downward motion of the ball, drop from the top we have. Now, from the top, from this, okay, what is the initial velocity? That is 0. What is the acceleration? 9.8 meter per second square. Okay. Now, we know that s is how much? Is x, because this distance we have taken as x, and t equals t. Okay. Applying the third equation of motion, s is equals ut plus half at square. We know that this is 0. So, x is equals to 0, because when initial velocity is 0, this will make time also 0, plus half into this is 9.8 and this is t square. T is what? Let it be t square. So, basically x is what? X is 4.9 t square. Equation number 1. Okay. Now, the upward motion. For the upward motion, this, the initial velocity was 25 meter per second. Acceleration, we have taken negative for the upward motion. S is 100 minus x and time is t only. Now, substituting this, also this in the equation, third equation of motion, s is ut plus half at square. Substituting the values, what is s? S is 100 minus x equals ut is 25t plus this is half, this is minus 9.8 and this is t square. No, solving this is actually, this will be minus 4.9 t square, so this will be 25t minus 4.9 t square. So, this is 100 minus x. Take this as equation 2. Now, this is equation 1, this is equation 2. You just adding 1 and 2. Okay. Now, do adding equation 1 and 2. See, x and 100 minus x, x will get cancelled. Similarly, 4.9 t square and minus 4.9 t square, that will cancel out. So, this will give you 100 equals 25t. You can have one more look. X is 4.9 t square, 100 minus x is 25 minus 4.9 t square. You add them, x and minus x will cancel, 4.9 t square minus 4.9 t square will cancel. This will give 100 equals 25t. So, t equals 4 seconds. So, they are going to meet at 4 seconds. Okay. Now, to find the distance, now to find x is what? X was 4.9 t square. So, that is 4.9 into 4 square, which is 4.9 into 16, which will give you answer 78.4 meter. So, basically the two balls will meet at a distance of 78.4 meter below the top. Okay. Next example. Now, a parachutist bails from an aeroplane and after dropping, means he goes out from the aeroplane after dropping through 40 meter. So, after dropping to 40 meter, then he opens the parachute and deaccelerates at 2 meter per second square. If he reaches the ground, now if he reaches the ground with a speed of 2 meter per second, how long was he in the air and at what height did he bail out from the plane? So at what height actually he comes out of the plane. So actually at what height he will out of the plane. Okay, so starting with this. Now when the parachute drops, parachute drops, so it has already covered 40 meter. So like when he is jumping from an aeroplane, his velocity u was 0. At 40 meter he drops out from the plane and A equals g, which is 9.8 meter per second square. Okay. We don't know the velocity that it attained, and take this time t1. So obviously there will be two time interval, the time taken when he was bailing out till a height of 40 meter, and then time taken when his parachutes open up and he lands. Okay, so using the third equation of motion, v square minus u square equals to 2as. Now we have to find v. We know that this is 0, so v square minus 0 equals 2. This is 9.8, s is 40 meter. So basically v is given as under root of 2 into 9.8 into 40. So calculating all this, this is under root of, this is actually 784, which is 28 meter per second. So now when he drops from the parachute, now when he opens the parachute, he is moving at a speed of 28 meter per second. There is one more thing. Now using the formula v equals to u plus at. Now we have all the values. V is how much? 28. This is 0 plus this is 9.8 and t. We can find t, actually this is t1 before opening the parachute. So solving this, t1 equals 28 upon 9.8. This will give you around like 2.8 seconds. So for 2.8 seconds he was in the air. Now the final velocity after the drop of 40 meter is the initial velocity for the rest of the fall. So means when he when he dropped, when he opened the parachute, he was already going down at 28 meter per second. So that is the initial velocity. So now next step is 28 meter per second is the initial velocity when he opens the parachute. So here you can write opens parachute. This is the situation when he opens the parachute. So u is 28 meter per second, acceleration down is minus 2 meter per second square. That is given to you in the question. He deaccelerates at 2 meter per second square. Okay. Now final velocity is 2 meter per second. So we have to calculate in this, take t as t2. Now using the formula v equals u plus at, substituting the values, this is 2, this is 28 plus this is minus 2 into t. Okay. So solving this, you take minus 2t, this is 28 minus 2, that is 13, 28 minus 2, sorry, 26. So t is 26 by 2, that is 13 seconds, t2. So t2 is 13 seconds. Okay. So the total time he was in the air is t1 plus t2, t1 plus t2. Total time will be, you can start from here. Total time t1 plus t2, which is 2.8 plus 13 seconds. 15.8 seconds he was in the air. Now again, when he opened the parachute, the height through which the parachute, that person having a parachute, has fallen during the second half is given by the equation. Using the third equation of motion, v square minus u square equals 2as. Now we know that he landed with velocity 2, this was 28 equals 2, acceleration was minus 2, and we have to find the distance s. Okay. Solving this, you get s as 195 meter. So basically the height of the aeroplane or the parachute, height of that parachute person which he falls down is plus 40, which is 235 meter, because 195 meter is the distance that he has traveled during the fall of the parachute, and 40 meter because from jumping out of the aeroplane after 40 meter he opened it. The 235 meter is the total height of the aeroplane. Okay. Next example. A balloon is ascending at a rate of 14 meter per second at a height of 98 meter above the ground. So 14 meter per second. Now, when a packet is dropped from the balloon, after how much time and with what velocity does it reach the ground? So you have to find the time and the velocity with which the packet will reach the ground. Again, taking the vertical downward motion of the packet from the point of dropping it from balloon up to the ground. See, it was moving up. So u will be minus 14 meter per second, because downward velocity we have taken as positive. A is down only 9.8 meter per second square, that's why positive. Height is 98 meter. Okay. So we have to find T, we have to find V using the third equation of motion. Sorry, second equation of motion. S is ut plus half at square. So basically this is by solving this, see, substituting the values. Okay, 98 equals, this is minus 14t plus half, a is 9.8 t square. Okay, so basically this will be 98 equals minus 14t plus 4.9 t square. Now, solving by the quadratic equation, or see, you can write this as, so this equation if you multiply it throughout this by 10, so this will be 980 equals minus 140t plus 49t square, and you divide throughout by 7, so this will be 140 equals minus 20t plus 7t square. Rearranging it, you can write this as 7 t square minus 20t minus 140 equals 0. Now, using that quadratic formulas, you get t, you get two values of t, like positive and negative. So, we will neglect the negative value and write the positive value. So, t is equals to 20 plus minus under root of 400 plus 3920 upon 14. So, like solving all this, 6.123 seconds, writing it up to 3 significant figures, neglecting the other value of time which is in negative. So, now this is time t. Now, to find v, the final velocity, using the third equation of motion, v square equals u square plus 2 as. So, this is minus 14 square plus 2, acceleration is 9.8 and this is 98. Okay. Now, solving all this, this is actually equal to 196 plus this will be 1920.8. So, total is 2116.8. So, v is actually under root of 2116.8. This is equals to 45.99 meter per second. So, this is how you solve this. Balloon is ascending at a rate of this. Body starts from rest, accelerates uniformly along a straight line. Now, at a rate of 10 meter per second square for 5 seconds. It moves for 2 seconds with uniform velocity of 50 meter per second. Then it retards uniformly and comes to rest in 3 seconds. Draw the velocity time graph of the body and find the total distance traveled by the body. Now see, they are saying the body starts from rest, accelerates uniformly at a rate of 10 meter per second square for 5 seconds. So basically, if we see that taking the motion of the body from 0 to 5 seconds, like from time 0 to 5 seconds, we have initial velocity as 0, final velocity we do not know, and acceleration is 10 meter per second square, that is given in the question. Okay. By using the formula V equals u plus at. Okay. So that V will be, what is u? That is 0 plus a is 10 into 5. So that is 50 meter per second. So basically the body acquires the body of 50 meter per second. It moves for 2 seconds. Now for 2 seconds it moves with the same velocity. Then comes to rest in after 3 seconds. Okay. Now we have to draw the velocity time graph. Now see, this is the velocity time graph, taking time on the x-axis and velocity on the y-axis. So basically from 0 to the velocity of, time 0 to 5 seconds, it requires a velocity of 50 meter per second. So we draw the graph like this. Okay, this is the graph. Now for 2 seconds, it moves with a constant velocity. So that means it is continuing for 2 seconds. So now, like for 2 seconds with a uniform velocity of 50 meter per second. So 2 seconds he continues with that. So from 5 to 7 he continues with that. Now, then it retards uniformly and come to rest in 3 seconds. So in 3 seconds, like 1, 2 and 3. At 10 seconds he comes to at rest. So 0 to 10. This is the velocity time graph. This is the velocity time graph. Like from 3 seconds that things comes to at rest. Now, draw velocity time graph of the body and find the total distance traveled by the body. Now, the total distance traveled by the body, as we know that the area under the velocity time graph. Now, this is the shape of a trapezium. Okay, you can name this as O, A, B, C. So, O, A, B, C is a trapezium and the distance is given by the area calculated. So, distance will be, now area of trapezium is half the sum of parallel sides, means AB plus OC. Now, OC is what? 10, AB is 2. So, 10 plus 2 into height means the distance between the parallel sides, which is 50 in this case, into 50. So, this is equals to 300 meter. So, the distance traveled by the body is 300 meter. Next example. Now, a particle starts from rest at time t equal to 0 and moves on a straight line with the acceleration as shown in this figure. Now, see, initially this was moving at minus 10 meter per second square for 2 seconds. After that, it moves at plus 10 meter per second square. Find the time at which the speed of the particle is maximum. Also calculate the displacement of the particle from starting point after 4 seconds. Now, here is the question. Okay, taking the motion. Now we have to start with taking the motion from 0 to 2. For this, we take a separate paper actually. From 0 to 2. From 0 to 2 seconds. Now, from 0 to 2 seconds. So, from 0 to 2 seconds. Now, we have, what is the initial velocity? Initial velocity is 0. Acceleration is minus 10 meter per second square. As we can see from the graph, this is minus 10 meter per second square. Okay. Time t equals to 2 seconds. Time to already 2 seconds. And V we have to find. V is the final velocity. Now using this v, first equation of motion, u plus at. So this v will be, u is how much, 0 plus this is minus 10 into 2. So basically v is minus 20 meter per second. Okay. Now again taking the motion from 2 to 4 seconds. Now time is 2 to 4 seconds. Now what is the initial velocity over here? Now first of all acceleration is plus 10 meter per second square, 2 to 4. But the initial velocity is minus 20 meter per second of the object. So u is minus 20 meter per second. Okay. A is positive 10 meter per second square and time is 2 seconds, as 2 to 4 is 2 seconds only. Okay. So the final velocity v is u plus at, that is final is minus 20 plus 10 into 2, which is minus 20 plus 20, which is equals to 0. The final velocity is 0. So the maximum velocity is at t equals to 2 seconds, and that is given as, and the value is minus 20 meter per second. Okay. Now the displacement of the particle from starting point after 4 seconds. So means total 4 seconds, what is the displacement travel? Now again taking the motion from 0 to 2 seconds. 0 to 2 seconds. Let s1 is the distance covered during this interval when the acceleration is minus 10. Using the third equation of motion, what is s1? That is equals to v square minus u square by 2a. 2a s1 is v square minus u square, that is minus 20 whole square minus 0 whole square upon 2 into minus 10. Solving this, this is actually 400, this is minus 20, so minus 20 meter. Now again taking the motion from 2 to 4 seconds. S2 is how much? V square minus u square by 2a. So v square, final velocity we have calculated, that was 0. So 0 minus, this is minus 20 whole square, and this is 2 into, this is positive 10. So which is minus 20 meter. So in both cases the displacement is minus 20, hence the total displacement is, the total hence the total displacement is minus 40 meter is the total displacement. Now example last. Now the distance x of a particle moving under one dimension, moving in one dimension under the action of constant force is related to time t, is given by the equation. Now this is the equation, t is root x plus 3, where x is in meters and t is in seconds. Now find the displacement of the particle when the velocity is 0. So to find when the velocity is 0. Now see, starting with this, what is given to us? Given is t is equals to root x plus 3 or root x equals t minus 3, squaring both sides. X will be t minus 3 whole square, which is equals to t square minus 6t plus 9. So x is t square minus 6t plus 9. Now on this step, differentiating it with respect to time. So dx by dt will be what? This will become 2t minus 6, this will be 0. So this is what? This is dx by dt is v. So velocity is 2t minus x. Now they are saying find the displacement of the particle when the velocity is 0. So velocity is 0 means this thing is 0. 2t minus 6 equals 0, that implies t equals to 3 seconds. So velocity is 0 at t equal to 3 seconds. Hence substituting t equal to 3 seconds in this, we find the displacement as 3 square minus 6 into 3 plus 9. So this is 9 minus 18 plus 9, which comes out to be 0. So displacement is 0, and displacement of the particle is 0 when the velocity is 0.